Today lecture that we're going to start is queue. So, what is a queue? Let's start with the little introduction of it. Before that, the topic we cover in today's lecture is queue introduction and queue algorithm, DQ algorithm, uh, introduction about circular queue and priority queue. So let's start with the definition of queue. Queue is a linear dynamic data structure which follows a first in, first out order to perform operation on the queue elements. So queue is a linear data structure. Why? Because one element is next to next element, the next element, the next element. So they are in linear form. Why dynamic? That during the execution of the queue, we can increase or decrease the size of the memory that we're utilizing. That's why we call it as dynamic. And it follows the first in, first out order to perform the operations on the elements of the queue. So very good example of the queue is the cinema hall ticket, or you can say a railway ticket. So whenever you go to cinema hall or some railway booking, uh, you are just standing in a queue. The person who is at the first position will borrow ticket first and then go out of the queue. And the person who's standing at the end of the queue will get the ticket at the end. And if a new person want to join the queue, that person will go after the last person in the queue, and that person will become the last person of that queue. So difference between stack and queue is in removing as well as adding. In a stack, we remove the element inserted at last. In stack, the last element that is added is the first element to be removed. Whereas in case of queue, we remove the item the inserted or located at the first location of the queue. So you can see that image over there. The people are standing in a queue to get some ticket from the teller, and the person at first position first to move out of the queue, or you can say first to be removed or deleted, and the person at the last in the queue the is the last person to be get out of the queue. And if we want to add some new person in the queue, that new person will be added after the last person existing in the queue. So this is what a queue is, and you can see in that image that queue looks like this, that we have marked 1 2 3 4 5 6. The first person marked as 1 is the first person who joined the queue. Second person joined the queue and that come after 1. Third person joined the queue that come after 2. Fourth person joined the queue that come after 3. Fifth person joined the queue that come after 4. And finally sixth person joined the queue that come after 5. So 1 become the first person and 6 become the last person. So this is what a queue is. A queue is an ordered list in which all the insertion at one end called rear end. Rear means from the last point. So whenever a new person or new element is to be added in the queue, that will be added at the last, or you can call it as a rear point. Deletion is made at another end called front. So the person who is front of the queue will be the first person to get out of the queue, or remove from the queue, or delete from the queue. Queue are sometimes referred as first in, first out list. So person who is added first in the queue will be the first person to move out of the queue. That is first in, first out. Few examples are the people waiting in the line at the bank cash counter form a queue. Whenever you go to a bank and want to get some cash, people are already standing in a queue, and you will stand at the end of the queue. It means we are adding the person at the rear end of the queue. And if you're a person who's standing at the first in the counter, then you the first person who get the cash. After getting the cash, you will move out of the queue. In computer jobs waiting in line to use the process for execution, this queue is called job queue. So the processor performs some task to process the some executions of the processes. Then the processes will be in some order. The process that is in the first will be processed first. and the process that will be at the last will be processed at last by the processor. So whenever we delete an element from the queue, we call it as a DQ. And whenever we insert an element in the queue, we call it as NQ. And you can see the image. The deletion of an element in the queue is done from the front side, and the insertion of the element in the queue is done from the last end, or you can say the rear end. So you can call it queue as first in, first out also, in which the element at first will be removed first and the element at last will be removed at the last. Some of the features of the queue are: queue is a linear dynamic data structure that do not consume a fixed amount of memory. Dynamic means whatever amount of memory is required, that will be used. No memory will get wasted. If you have some extra memory, it will be used by some avail component in which empty memories are stored over there. Each insert and delete operation increase or decreases the size of queue by 1. So whenever we insert an element in a queue, the number of element increased by 1. So you can see in this image, earlier it was 1% in the queue. When second person come, 1 plus 1 become 2. When third come, 2 plus 1 3. Then 3 plus 1 4, 4 plus 1 5, 5 plus 1 6. It means the each insert and delete operation increases or decreases the size of queue by 1. If you remove one person from the queue, automatically the number of person in that queue is reduced by 1. The starting point or the starting pointer that points to the first item of queue is front. The starting point we call it as a front of the queue. The last pointer that points to the last item of the queue is called a rear. And the person or the item at the last of the queue, we call it as the item at the rear end. That's the last end. Existing elements of queue is deleted from first location, or you can say a front location. New element in the queue is inserted from the last location, or you can say a rear location. So if I want to remove some element from queue, the element will be removed from the front end. If I delete element from the queue, it will be removed. Or if I want to insert the element in the queue, that will be inserted from the last end. After the features of the queue, we go to the various operations that can be operated on queue. So what are the operations? NQ means that we want to insert or want to add some new element at the end of the queue. So add an element into the queue. If the queue is full, then it is said to be an overflow condition. We have always used some particular size of a queue. Let's say the size of queue is maximum 10. So I can insert only 10 elements in the queue. If I want to insert 11th element, the computer gives the message it's already full. So you cannot insert. We call it as an overflow. So if you have a glass of water totally filled, and if you want to fill more water in it, that water will overflow. It's fall down from the glass. That's why I call it as an overflow. DQ means to remove an element from the front side of the queue. So remove an element from the queue from the front side. The items are deleted in the same order in which they are inserted. So first element will be removed first, second element then after first, third element after second, and so far so on. And if the queue is empty and we perform the delete operation, how we can delete an element from the queue if the queue is empty? If such type of condition occurs, we call it as underflow. If the queue is empty, then if we perform the DQ operation, it is said to be an underflow condition, that we cannot delete an element if the queue is empty. If you want to try to perform some operation of DQ, then you will get a message, you are under flow. You cannot delete the element from the queue. So the element at front side with the first element to be removed. The element at the rear side will be the last element, and the new element will be added at the rear point. So main operations are NQ and DQ. So we cannot insert the element in between the queue, and we cannot delete the element from the queue in between the location. So we can delete only from the front side, and we can insert only at the rear side. So this is an algorithm of the NQ. So what an NQ is? So algorithm of NQ. So QINST is the name of my algorithm. Size, rear, front, queue items are some of the variables I have used in my algorithm. So QINST is the name of the algorithm. Size is the maximum number of element queue can hold. Rear variable represents the last location of the element in the queue. Front variable represents the first location of the queue. And queue is an array used to create the queue. And item is the new element that I have to insert in the queue. So I have represented some, give some introduction, very brief introduction about my algorithm, that what is the meaning of each and every word and why I have used over here. QINST is the name of the algorithm. Size is the maximum number of element that I can enter in my queue. Rear is the variable that represents the last location. Front is the variable that represents the first location. QUE is an array, name of the array that I have used to create the queue. And ITEM is the name of the new element that I want to insert at the rear location of the queue. So this is my algorithm. QINST, size, rear, front, queue, size, and item. As you know, whenever we start an algorithm, it always start with the first point as start. And if rear is equal to size, if my queue is already full, let's say the size is 10 and the rear location is also 10. It means the last person starting in the queue is at location 10. So how can I add the next element if or there are 10 elements are already in the queue? Because I can insert maximum 10 elements in the queue. So it means queue is full and the computer gives the message that overflow. Queue is full. You cannot add a new element because maximum size of the queue is 10 and you already have 10 elements in the queue and you cannot insert the 11th element. If you try to insert the 11th element, you will get the message overflow, queue is full, and you get exit from the process. Otherwise, if rear is not equal to 10, if front is equal to 0 and rear is equal to 0, it means my queue is empty. There is nothing in the queue. Front is 0, rear is 0, no one in the queue is empty. If I want to add some new element, that element will come at the location number 1. If location number 1 means the front become 1 and rear is equal to rear plus 1. If there is some element in the queue, then I will make rear equal to rear plus 1. That element will be added at rear end and I stop my if condition, that is in step number 2. Fine. So this is the program, how it will run. Maximum size is 10, rear is -1, and set the loop while rear is less than size. So we keep on running the loop when value of rear is equal to value of size. Because we started the loop from 0, that's why we take over here rear less than size. Please enter the value of element you want to insert, enter some value, then you have enter first value, rear is equal to rear plus 1, you come enter second value, then rear equal to rear plus 1, third value, again plus 1, fourth, fifth, sixth, seventh, eighth, ninth, again rear equal to rear plus 1, that become 10. So you can enter only 10 elements over there, not more than 10. If you try to insert more than 10, you get a message overflow. So when we go for the lab, we will perform this action, how overflow will occur. This is one of the example over here. My loop starts from 0. I entered first value, that is 1. So then rear equal to rear plus 1, rear become 1. I enter second value. Then rear equal to rear plus 1, that become 2. Third value, fourth, fifth, sixth, seventh, eighth, ninth. That q of 9 means that's the 10th value because my q starts from 0. If you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, that become 10 values. And if I want to insert next value after 9, I get a message over there, overflow, that I cannot add more elements because the size of my queue is 10. If I try to add one more value, I will get the message overflow. Let's start with an example of it so that you can understand how I can do it. This is one of the example. The front is 0, rear is 0, size is 10. That I have nothing in my queue. If I insert first element as 14, then front become 1, rear become 1. If I insert second element 20, front remain as 1, rear become 2. If I add the third element 30, the front become 1, rear become 3. If I add fourth element, rear become 1. Front become 1, rear become 5, 4. If I add fifth element, front become 1, rear become 5, and so far so on. If I add 10th element 55, front become 1 and rear become 10. And if I want to insert, let's say 11th element in my queue, size of the queue is what? Size of my queue is 10. So it's already full. You can see elements are already in the queue. If I want to insert the 11th element, I will get a message of overflow. That is, you cannot insert the new element in the queue. This is how the queue insert works. Queue, next is the DQ. DQ means that I want to remove the element from my queue. So QDEL is the name of my algorithm. Size, rear, front, queue items are the important parameters or variables that I have used in my algorithm. QDEL is the name of my algorithm. Size is the maximum number of element a queue can hold. Rear represent the last element in the queue. Front represent the first element in the queue. And the queue uh, is an array used to create queue. So queue is an array. QUE is the name of the array that I have used to create the queue, and the item represents the element or that I want to delete from the queue. So whatever element I will delete, so I represent that element is item. Obviously, that element will be the first item that will delete from the queue because the elements are always deleted from the front end. Item represent the element and deleted from the queue. So you can see this is my that I have queue I have created over here. So I remove the last point over here. Okay. So this is my queue. I'm having 10 elements over here: 14, 20, 30, 1, 4, 15, 23, 9, 19, and 55. So I will make it as front, and you can call it as rear. Fine. So F means front, R means rear. So you can see the value of, let's come over here, the first point. So you can see the front value is 1 because we want to delete it, and the value of rear is what? Is 10. The front value is 1, rear value is 10. So my queue is already full. Now if I want to delete, let's start the algorithm first, then we move on. Start. If front equal to 0, then print underflow. Front equal to 0 means no element is there in the queue. If no element is there in the queue, how we can delete? We cannot delete. Then exit out of the program or process. set item is equal to queue of front. So whatever element is at the front will be stored in the variable that we called as item. Fine. So if front equal to rear, it means we have only one element over here. We have only one element in the queue, and if we delete the one element, then after deleting the element, the queue will become empty. Fine. And after that, if there are more than one elements in the queue, if I delete the front element, then the front will become front plus one, and end of the queue. How it works? Let's start. Uh, front is 1, rear is 10. If I want to delete the first element, fine. So I want to write over here that item equal to queue of 1, because I want to delete the first element. Because as per the statement of queue, we can delete the element from the front side. Front is 1, this is the first element. Item is queue of q1, it means the item will become 14. That first element I want to delete from the queue is 14. So it means I will change it. The front will become now 2, because the first element deleted, and the rear become 10. I will make it as 10, and front is 2. So I copy and paste over here, much better. Copy and I paste over here. Fine. The first element is deleted. Now that at top location is at first element is at location number 2. If I want to delete the element at location number 2, because this now this become the top, I write over here. Now this become the front. Fine. And I use some shape over here. Yes, this become the front. Fine. The front element has to be deleted. Again, I delete this element. I delete item. That is 20, I think. It was 20. If I delete this element, it got deleted. It means now front value will become what? Front will become 3. So I move the front from here to here. Now this become front. Fine. After that, again, if I want to delete this element, I delete this element. That element will be stored in where? The variable item. What was the value of the item is 30. Item is equal to 30. If I delete this element, again this get removed from here. Now the front will become what? Front will become this one. I'll change the value over here. This become 4. Similarly, I remove this one. I call it as item is equal to 1. If I remove it, this get removed from here. Then the front will become 5. This become the front element. So I keep on removing all the element one by one. Fine. So when I reach at the location number 8, so here item become 19. So this got removed. Now front become 10. Now you can see over here when front is equal to rear. You can check over here in the algorithm when front is equal to rear. You can see the front is 10, rear is 10. Both are having one same value. It means one element in the queue. So you can see all the elements are deleted. We have only one element in the queue, that is 55. The rest all elements are deleted. Fine. It means if I want to delete this element, I come over here, I got it as front. So I want to delete this one. I write over here item is equal to 55. I want to delete it. It means now front is 0 and rear is 0. Nothing is there in the, no one is there in the queue. All my queue is empty. I remove over here also. I write over here front equal to 0 and rear equal to 0. Nothing is there. If I want to perform some delete operation, nothing is there. If I perform to some delete operation, delete, then I will get a message. What message? Underflow. How you can delete an element from the queue if there is no element in the queue. Fine. This is how the del queue works. We are having a queue that having 10 elements, 0 to 9. So currently queue is empty. Size is 10. Front is 1 is 1, rear is 1 is 1 as per the program we have done, because our queue starts from 0. We cannot write 0 over here. If we write 0 over here, it becomes the first location. That's why we write over here -1, because my array starts from location number 0 to 9. This is 9, not 0. Huh? Make it as 9 over here. So my this array starts from 0 location, so I cannot write 0 over here. If I write 0 over here, this becomes the first location. That's why I write over there front -1, rear -1. This means if the delete operation is performed, it is underflow. That I cannot delete an operation an variable from my queue because my queue is empty. Okay. First element is inserted in the queue at the first location. One element in the queue, size is 10, front is 0, rear is 0. You can see only one element is there. 22 will remain as the front and 22 will remain as the last. If only one element is there, that remain the front, that remain the last. So I write over here one element in the queue, size is remain as 10, front is 0, rear is 0. So if delete operation is performed, one element deleted, queue again get empty over here. If I want to delete this particular value from the queue and I delete the value, again my queue get empty. Again my queue will become empty. Because there was only one element, I perform the delete operation over here. If delete operation is performed, one element deleted, queue get empty. So front is 0. Now I'm having, let's say 1, 2, 3, 4, 5, 6 elements over here. So I'm having 6th element over here. My first element starts from 0 and 6th element is at location number 5 because the queue starts from 0. So 6 elements are in the queue. Total size is 10. So front is 0 and the rear is 5. So if delete operation is performed, one element deleted from the front. Front is this location. After deletion, front become this one. The first element get deleted. Now this become the front location because 22 is get deleted from here. Now number 3 is in the first location. That is the front location. And the last one is 9. Q5 is 9 element. So this is the algorithm how it will work, that if I want to delete an element from the queue, if front is 0, queue is empty. Else item is equal to, that is on the front. If front equal to rear, it means we have only one value over there and we delete it, then front becomes 0, rear becomes 0. This is how it will work. Next is the topic we're going to start is a circular queue. So what is circular queue? Location of the queue are viewed in a circular form. So you can see the image. The first location is viewed after the last one. So you can see 1 is at the front location, 6 is the last element, that becomes the rear location. And maximum size of my array is 8. So I can enter only 8 elements over here. So 2 are still empty. I can add 2 more elements over here. So I mentioned over here front 1, rear 6. So first location is the front location, and 6th location become the rear location. Still 2 locations are empty. Maximum size is 8. So I can still add more 2 elements over here. Overflow occurs when locations are filled. So if I fill this location also, then what will happen? Overflow will occur because all the queue got filled. This become the overflow. Earlier this was the rear. Now these 2 elements are also filled. No more empty space in my queue. If I want to add some more elements over here, then I got the overflow. So 1 is the front location, 8 is the rear location. Maximum size of the queue is also 8. It means my queue is already full. I cannot add more elements in the queue. If I try to add some more elements in my circular queue, I will get the message of overflow. Fine. So how to add an element in a circular queue? So let's have the algorithm of that. So CQ insert, I call it as the name of my algorithm. Queue front rear item are the important variable I have used in my algorithm. I start over here. CQ insert is the name of the algorithm to insert new element in the queue. So this is the CQ insert is the name of algorithm. Queue is the name of the array that I have used to create the queue. And front is the variable described starting point of the queue. Rear variable describe the end point of the queue, and the item is the new value that I want to insert in the queue. So CQ insert, this is the algorithm, declare queue front item as integer. If front is equal to 0, then set front is equal to front plus 1. So you can add new element at the front plus 1 location, that is location number 1. So take this 7 point very seriously. What's the second 7th point is telling us? If rear is equal to maximum size, if rear is equal to maximum size and front equal to 1, let me go back over here and check over here. Rear is equal to maximum size. Maximum size is 8. Now rear is equal to maximum size and front is 1. So look at the image. The value of front is 1 and rear value is 8, and 8 is what? 8 is the maximum size. Fine. Then what will happen? Or it said or rear is not equal to 0 and front is equal to rear plus 1. If rear is not equal to 0 and front is equal to rear plus 1, then print queue overflow. It means that our queue is going to overflow. All the elements of queue are filled. Fine. If rear is equal to max size, set rear is equal to 1 or set rear is equal to rear plus 1. Let me give some example over here. Okay, it will come later on. No problem in that. Okay, if rear is equal to 1, set rear equal to rear plus 1. Then we give the value over here. So how we can explain it? Let's take you in this figure over here. I'm having this circular queue of maximum size 8, and I NQ means I add some new element in my circular queue. The first front will remain as 1. Earlier rear was 6. I add one new element over here. So I got 7th element. Rear becomes 7. Still I am having one empty space over here. I can add one more element over here. So what I do is in this figure, what I did is that I remove this 1, 2, 3 elements. I remove this 3 element. I delete these 3 elements. Fine. When I delete the 3 elements, what happened? Does this become the front and this become the rear? So this is 1, 2, 3. If you remember, this is the 1, 2, and 3. So if rear is equal to maximum size, if rear is equal to maximum size, I want to insert one more element because 3 locations are empty over here, and this location is location number 1. This is 2. This is 3. If I want to one more element over here, when rear value is maximum size, then I set rear is equal to 1. So you can check over here. If rear is equal to maximum size, over here rear is maximum size 8, and I want to add some more element in it, then I set rear is equal to 1. Then the rear will become 1. 1 means at first location I'm going to add the new element. Now you can see it become a circle. Again I come back to first location. After a last location, my last location is joined to the first location because the first location was empty. Now if I want to add some new element, that new element will be added at the first location because this is my circular queue. So in circle I keep on rotating. if I am having any empty space. Fine. Again, if I want to add some new element, then rear is equal to rear plus 1. That becomes second location. If I want to add some more element, then rear is equal to rear plus 1, 1 plus 1, 2. At second location, I can add some more element. Again, more element, rear plus 1. This becomes location number 3. I can add one more element over location number 3. And my whole queue will get filled. Then it will get overflow if I add some more element over here. In such a way, all elements are filled. So this is the front, this is the rear. All my circular queue is filled. If I want to add some more element in my circular queue, no space is empty, I will get the message of overflow that you cannot add more elements in the queue. This is how the circular queue will perform the operation of inserting an element in the queue. Fine. And similarly, if I talk about the DQ, that I want to delete an element from circular queue, then CQ delete is the name of the algorithm. Q, front, rear, DQ, Q, front, rear are some of the important variable I have used. CQ delete is the name of the algorithm. Q is the, you can say, act as a array that I have used to create a queue. Front defines the first element and rear defines the last element. I started my algorithm with start. If front equal to 0, it means nothing is there in my queue. My queue is empty. In fact, my circle queue is empty. If I want to perform some operation, then I will get a message that you cannot delete an element. You will get underflow. So set item is equal to front of queue. So whatever element in the front will save in the item variable item. Else if front is equal to rear, both are having same value. I'm having only one element in the queue. If I delete it, then both remain 0. My queue will become empty. So if front is equal to max size, then if I delete the element from front location, then my front will become 1. Because last location will be deleted. I have only one element. After deleting the one element that is the last location, then again it's a circular queue. It comes to the first location if I want to add. This is how we can perform the operation. How it works, this is the front, this is the rear, because in the queue whenever I want to delete an element, it's always get deleted from the front side. That is the 1. I remove the first element, it means second become the front and 6 remain as rear. Fine. And if 8 is the front element and 4 is the rear element, so because this is the maximum size, if I remove the 8th element, the 8 will get removed, then 1 will become the front. If 8 get removed, then this become front and 4 remain as rear. And if I want to add something, that will come after 4. So this is how we can represent if my queue is empty and I want to perform some delete operation, I will get a message of underflow that you cannot delete the element from your queue because your queue is empty. Fine. This is how we can perform the DQ operation in our queue. Next point is the priority queue. So priority queue is a collection of elements such that each element has been assigned a priority, such that the order in which elements are deleted and processed come from the following rules. What rules are that? An element of higher priority is processed before an element of low priority. Two elements with the same priority are processed according to the order in which they are added in the queue. So two types of queues are there: ascending priority and descending priority. Ascending priority queues collection of item to which item can be inserted arbitrary and from which one only smallest item can be removed. Descending means that collection of item into which item can be inserted arbitrarily from which only largest element can be removed. So I hope you understand the concept of the queue and understood all the process. What is a queue, and circle queue, and priority queue? And thank you for attending the class.